Okay, so now that we've tracked the object, we come to the interesting part, which is analyzing the data that we can get from this. And this is quite powerful in that it has a lot of data that we can extract from what we've done so far. So I'm just going to, the data is all contained in a data table at the bottom here, and you can decide which quantities you want to be there. So say if you're interested in the vertical position, the speed, and the acceleration, maybe also the kinetic energy, you can include all of those. And all of that data can be used and copied into spreadsheets to analyze. So yeah, all we need to do that is just click there and then Control A and then copy, and then we can put it into whatever spreadsheet we want to, or data logger, or whatever it is that we want to use to analyze it. However, this program itself does a lot of the graphing stuff for us, so most of the things that we want to do we'd be able to do in here. So I'm going to minimize the data table because I'm more interested in the graph at the moment. And so here at the moment it's plotting the it's plotting the horizontal position against time, and you can see that it starts off at negative x. Remember, we defined 0 as being down here, so it's currently in the negative horizontal direction, and as we play it's moving in the positive direction, and then it goes past 0, and then it comes back a bit, and then it goes forward again. So but that's not particularly interesting. What we're mostly interested in is the speed firstly. So we'll choose velocity magnitude here. And that gives this interesting graph of velocity against time. And we can see that it starts off with 0 velocity at the top of the ramp here, and then it accelerates to a very high velocity, peaking here. If you click on that point, it'll go to that frame. So this position here is where the velocity was the highest, which makes sense because that's also the lowest point. That's where it's lost all of its gravitational potential energy. This point here corresponds to when it's at the top of the loop here. And this point here is when it's back down the bottom. You see this peak is not quite as high as that peak. It must have lost some energy before getting there, probably due to heat. And then here we can click, that's presumably when it's on the top of the crest here. Okay, so the velocity time graph is quite an interesting one. So if we want to copy that one into our report, we just go to Edit, Copy Image, Plot View, and it'll copy whatever graph you have in the plot view. Alright, so the next little task that we want to do is to fit a line to this data, because I'm interested in finding out what the acceleration is during this first part of the journey. So I want to be able to fit a line so I can figure out the gradient, and the gradient of a velocity time graph is the acceleration. So I'm going to go to View and choose Data Tool, Analyze. And you'll see I get a copy of my graph here, but in this tool I can select a piece of data that I'm particularly interested in, which is I want to know what's going on during this part, which is almost a straight line because it's accelerating down a constant slope. And I can choose Analyze here and choose Curve Fits, and that'll fit a straight line to those points and those points only. I'm just going to zoom in on them so that I can see that a bit better. So here, the pink line here, I can change that color so it's not so close to the other one. What's a good color? Red. No, blue. Okay. So the blue line here is my line of best fit for those data points. And it also gives the equation here. So V is equal to AT plus B. A here is the gradient, and so that will be my acceleration. And so it's 7.657 is the meters per second squared. The E0 here means it's times 10 to the 0, which is times 1. So this just tells you sort of what order of magnitude you're in. Okay, so now we've fitted that line. So to copy this graph into your report, just go to Edit, Copy, and we want to copy an image of it. Otherwise it'll just copy code. So we want the image. Okay, so we fitted a line to it. Now, the next little bit in the analysis that's useful is if we click on here, we can change what we're graphing, and there are a lot of options here. So we can look at the vertical position, we can look at the horizontal velocity, we can look at the vertical velocity, but you'll notice that there is a kinetic energy one here, which shows that as it gets faster, obviously it's going to have more kinetic energy. But it's also interesting for this one to plot the potential energy, and there is no potential energy function here. So what I'm going to do is define a new function, and this is going to be potential energy. So under data functions here, we can add a function, and it doesn't like spaces, so we're going to double click on that name box, and we're going to rename this potential energy, and then underscore J for the unit. It doesn't like brackets and it doesn't like spaces. So, and then we need an expression for this. So how is it going to work this out? It's going to work it out by taking the mass times 9.81, which is G, times the change in height. But if we look at our graph here, 0 height is here, and the height is just going to be the vertical position, which is what we call y. So I'm just going to choose that variable here, y, and then hit enter. So now I have this new term here. I can close this, and now we'll see that on my axis here. So potential energy has now appeared there. So now I have a graph of potential energy against time, and so it's used the mass that I've entered for this trolley. It's multiplied it by 9.81 and multiplied it by its height. And so this now shows what the potential energy is at various points. So the potential energy at this point is there. Oh, hold on, it just appeared. So if I click on that, I can read off here in this yellow box what the potential energy is, and it's 0.345 joules. At the bottom here, the potential energy is very close to 0. It's 4.979 times 10 to the minus 3. So that means it's 0.004979. Okay, so we want to copy this graph that we've created of potential energy. So we'll go Edit, Copy Image, Plot View. Okay, so I think we've now covered everything in the last section as well. So yeah, it asks you to find some of the values. So you can find it at the top of the hill by clicking here, at the bottom of the hill by clicking here, at the top of the loop, which you're not asked for, but you could find it at the top of the loop by clicking there. Okay, so I think now we're pretty comfortable with all of the different functions of this tracking software. The next task is going to be to choose which type of motion you would like to analyze, and there are several options, and then to get started on tracking that video. And there'll be some tutorial points, because there are some things that are different about each task. Just ask if you need extra help.